Section 1.4, linear inequalities in one variable. So we see ax plus b is less than 0 or ax plus b is greater than 0. These are known as your open circle inequalities. So normally when you're writing interval notation, you're going to use parentheses around them. If you see it in the format as ax plus b less than or equal to, that's what that little line underneath the inequality symbol means, to 0, or ax plus b greater than or equal to 0, these are known as our closed circle inequalities. So normally when we write interval notation, you're going to use brackets either on both the left and right side of the numbers or on one portion. If in any moment you're going to use negative infinity or positive infinity, they will contain parentheses around them. So if you're using from negative infinity to positive infinity, they will both have parentheses around both symbols. If it happens to be a combination of an open circle or a closed circle, the inequality interval notation will have in parentheses around the infinity symbol, but either a parentheses or bracket around the numerical value. So an example of interval notation is shown here. It says the parentheses of negative infinity to 3. So it means all the values to the left of 3, so from positive 3 negatively, will make a solution statement. Set builder notation is where you write it where x, if and only if, that's what that line means, x, if and only if x is less than or equal to 3, so which means all the values of x are going to be smaller than 3 or equivalent to 3. So in example 1, they want us to solve it, graph the solution, write it in interval notation, and then write it in set builder notation. So we're looking at the example. It says 3x minus 7 is greater than 2 times the parentheses x minus 4 minus 1. So remember, in order to move anything from left to right or combine like terms, think of the inequality symbol as being your equal sign. Before we can do anything, we need to distribute the 2 in. So we're going to distribute the 2 in. So we see 3x minus 7 is greater than 2x. 2 and negative 4 multiply to be negative 8, and then negative 1. You're going to combine your like terms on the right side of the inequality. So 3x minus 7 slides down. So 2x, I'm short $8 and then short another $1 I didn't have, so I'm now short $9. Now we can do our movement. So think of the inequality symbol being the George Washington Bridge. The left side is New York, the right side is New Jersey. So I want to move the 2x from the right to the left. It's positive 2, so opposite is negative. Bring negative 2x over. So we see x minus 7 greater than negative 9. Do the same thing. It's now negative 7 leaving New York and going to New Jersey, so we're adding 7. So x is greater than negative 2. So our solution says x is greater than negative 2. They wanted us to write it in interval notation. First thing I notice, it's only an inequality. So it means that this is an open statement. So, and notice where the arrow is pointing. The arrow is not pointing to the negative 2, the arrow is pointing to the numbers after the negative 2, so which means it's headed to positive infinity. So since I'm going to positive infinity is going to be the right portion of your interval notation. I started at negative 2. That's going to be the left side of the interval notation. And because it's an open statement, I have to use a parentheses around it. So there's our interval notation. Then they wanted it in set builder, which if you look at your solution statement here, you have portions of your set builder notation. This is part of it. So you're going to write your set builder notation emblem, write an x because we use the variable x in this problem. So if there had been y's, it would be a y. If there had been t's, this would be a t. If there had been the letter c's, then you'd use a c here. It's depending on what variable you have. So it says x, where, if and only if. You're going to write your equation solution here. X is greater than negative 2, and then close the set. That is your set builder notation. So when you're multiplying and dividing by a negative number attached to a variable, you must, and that's why it's capital letters, you must change the direction of the inequality symbol. So in order to explain this, we're going to do an example 2, and it says solve. They want us to solve it. They want you to graph it. They want us to do interval notation of it, and they want set builder notation. So our problem says negative 6 parentheses, x minus 3, close the parentheses, greater than or equal to 2 minus 2 parentheses x minus 8, close the parentheses. Before we start this problem, first thing I notice here, there is a line underneath it says greater than or equal to. So we know that we are a closed statement, which means brackets are going to be involved. So if you want to specify specific problems and key information, you can always jot down little side notes. So before we can do anything, we need to distribute. Now notice here it says 2 minus 2, but it has times of parentheses. Do not subtract 2 minus 2 and tell me 0. We are distributing -6 into here and -2 in the second parentheses. Do not combine like terms. That is a careless mistake, and I don't want people making mistakes like this. So we see -6x, -6 and -3 makes it positive 18, greater than equal to. 2 slides down. Now I'm distributing the -2, so we become -2x. -2 and -8 is positive 16. So now we've expanded out of our parentheses. The left side is already collapsed, but on the right side you can combine like terms. So first thing we're going to do is combine our like terms. I see -6x plus 18 greater than equal to. So I'm going to write -2x. I had $2 and gained another 16. I have 18. We're crossing that bridge. Think of this as being the George Washington Bridge again. So now it's -2x. I'm adding it to the left side. And I know that it makes it negative. It's okay. You always want to try to keep your variables to always moving to the left side, especially when working with inequalities. So we see -4x plus 18 greater than equal to positive 18. Subtract the 18 over. So we get -4x is greater than equal to 0. Now, remember what we talked about, said when multiplying and dividing by a negative number attached to a variable, you must change the direction. So here, I don't have x by itself, it's not isolated, but I'm dividing by a negative number. So when I divide by the negative number, instead of being greater than equal to, I become less than equal to. I change the direction of the equality. So now x is less than or equal to, now 0 divided by anything is still 0. So our solution is x is less than or equal to 0. Remember, we want interval notation. So we're going to start with interval notation, and then we'll go to graph it and set builder. So interval notation says 0 is the biggest point value. The arrow tip, our inequality symbol, is not pointing to the x, it's pointing to the values after, to the left of 0. So it's headed to -infinity, and it started at 0. But because it's less than or equal to, instead of parentheses, you're going to use a bracket. Set builder. We already have our equation right here, so that's what we're going to use. So since the variable is x, so x, if and only if x is less than or equal to 0, close the parentheses, or your set builder. And then the part that we need to learn is your graph portion. So think of it in a graph line, your number line. When you're graphing these type of problems, you don't have to put every little tick mark. You're going to put a starting point, so I'm going to put a 0. I'm going to say there's a value, say this is a -5 because the arrow is pointing to the left of 0, so it means negative values. Now, it says it is a closed statement is what we came up with. Since it's a closed statement, you have a solid circle, and the arrow tip is pointing to the left. So it means all the values to the left of 0 will make the statement true. Example 3. Again, they want us to solve it, graph it, interval notation, set builder. So in this situation, we have a fraction involved. So it says -5x plus 2, all divided by -3, greater than x plus 2. So first thing I'm going to do is I'm going to treat this as a fraction by putting it over 1. So I have a fraction and a fraction. Next thing I notice is it's only got the greater than symbol, so we know that we are in open statement. So it means we use parentheses. So if I want to get rid of this fraction, notice that it's a negative. So first thing, notice that this is a binomial piece up here because there's two terms. I'm going to put parentheses around it. as well as the second side. I am going to multiply both sides by -3. And the reason I did that is because remember the rules. When you multiply or you're dividing by a negative number, you're flipping the direction of the inequality. So -3's cancel, leaving you with -5x plus 2 is now less than. Change the direction. -3 times the parentheses x plus 2. Before we can do any movement, you need to distribute. So we have -5x plus 2 less than -3x. Negative and a positive makes it -6. Add 3x over. So become -2x plus 2 less than -6. Subtract the 2 over. -2x is less than -8. And then divide. Now we're dividing again by a negative. So it changes the direction. X is greater than +4. So now x is greater than +4. We know it's an open statement. So we're going to start first with graphing it. I'm going to put 0, so that's a neutral point. Here's our +4. Now it says all the values of x are greater than 4, which means the arrow is pointing to the right, so it's going to positive infinity. So at 4, we are in open circle headed to the right. Then they wanted us to do interval notation. Again, remember, it's an open statement, so it means parentheses. The arrow is pointing to the right, so it's headed to positive infinity. It started at 4, but since it's an open, I'm using a parentheses. And then our set builder. Remember, set builder, they already gave you the setup, so your set builder notation, x if and only if x is greater than 4, close the set builder. Example 4 says Beth received grades of 97%, 82%, 89%, and 99% on her first 4 algebra tests. To earn an A in the course, she needs an average of 90% or more. What scores can she receive on the 5th test to earn an A? So first things, she received a 97, an 82, an 89, and a 99 on her first 4. It says to earn an A, she needs an average of 90 or more on the 5th test. So think of back in your early days of mean, median, mode. So this is talking about mean average. So remember, if you're trying to calculate your exams, you want to know what should I get. So let's look at our things. They tell us a 97, an 82, an 89, and a 99. Those are her first 4. It says to earn an A on the course, she needs an average of a 90 or more on a 5th test. So the test that we don't know, I'm going to use the variable x. And when we're looking for average, it's looking at 5 exams. Now they says the average of 90 or more means that her average has to be greater than or equal to 90, not less than or equal to 90. It needs to be greater than or equal to 90 because I can have a 90 exactly and still have an A. If I have an 89, I do not have an A. So first thing before we can do anything, we're going to add up our test scores. So we see 97, 82, 89, 99. We have a 367 possible points so far, plus our x that we need, that we don't know, over 5 greater than or equal to 90. Think of this as a fraction bar again, so I'm going to put it over 1. I want to get rid of my fractions, so I'm multiplying both sides by 5. So the 5's cancel. So we get 367 plus x is greater than or equal to 90 times 5 is 450 possible points. And now subtract the 367 over. So x is greater than or equal to, so 450 minus 367 and 83. So it's asking what scores can she receive. So Beth can receive the lowest possible score of an 83 on her 5th test and still achieve an A average. She can score a 99 on the next test and still have an A average. So her set builder means x if and only if all the values of x are greater than or equal to 83. So this includes all possible values. Because remember, at 100%, you don't go past 100. So that's where we're saying x is greater than or equal to 83.